Okay guys, let's go ahead and discuss our warm-up question. This warm-up is similar to what you're going to be doing in class today. So I wanted to use this opportunity to discuss just one more example of how we can represent the same motion with two different types of graphs. Your assignment today is going to be matching those graphs together in a card sort. That's a digital one on Desmos, so I'll show you that in a minute. But for right now, I want to go ahead and go over the warm-up question first. So this is what it looks like in My Open Math. I'm going to zoom out so we can see both of these at the same time. And what we're going to do is it tells us if the object shown in the graph starts at the reference point. Okay, I had to tell you that because I mentioned yesterday you cannot tell where an object starts when you look at a VT graph. Okay, or a couple days ago, I don't think that was yesterday. But you cannot tell the starting point. So the question's going to tell you where it starts, and it says reference point, that's going to be our 0, whatever our 0 is. Okay, so we're going to start at the origin on this graph down here, and we're drawing an XT graph. So we're going to go from VT to XT. So when I look at this VT graph, my object for the first 2 seconds is traveling at a constant velocity of -3. So over here, to show that, I'm going to start at 0, so I'm going to click, okay, and then I need to show a constant velocity of -3 meters per second for 2 seconds. So that means after 1 second, I would have traveled -3. I'm going to have a negative slope here. After 2 seconds, -6. Do you guys agree with that? Okay, that's the area, remember? Under this is what we're doing here. And so I'm going to go at 2 seconds to the point at -6, which is right there. Okay, then it says that the object somehow immediately changes its speed. This graph is not realistic at all, but immediately changes its velocity from -3 to +3 without slowing down or speeding up. Okay, which is fine. And so we're going to represent that +3 meters per second for 2 seconds because it does that from 2 to 4 seconds. And so we're going to go right back where we started. Okay, because after 2 more seconds, it will have traveled 3 and then 3 more, which is going to bring us back to 0. Okay, and I know that because the areas of those 2 rectangles are equal and opposite. We talked about that the other day as well when we talked about how to read these graphs. Remember, the area under that graph tells me how far I've gone. So I went -6 and then I went +6. I'm back where I started after 4 seconds. The next 2 seconds from 4 to 6, I travel 1 meter per second and I do it for 2 seconds. So I'm going to go 2 more meters forward, and so I would show that 2 meters forward, and it takes 2 seconds to do it. So after 1 second I'd be 1 meter, 2 seconds I'd be 2 meters. It's going to look like that, and I'll zoom in at the end so you can see it better. And then my velocity is 0, which means I am not moving, so I'm going to stay in the same position for the next 2 seconds. This is what my graph looks like that shows the exact same motion as the one we had on the screen a second ago. Okay, so again, it shows I'm going backwards. It shows that here. Sorry, if I move the mouse, it's going to do that. It shows that I'm going backwards for the first 2 seconds, 3 meters per second for 2 seconds. That's my slope, -3. Then it shows I'm going forward 3 meters per second for 2 seconds. That's my slope, +3. And then it shows a slope of 1 because I'm going 1 meter per second forward for 2 seconds. And then a slope of 0 because I stop. Okay, so again, we've talked about this. Today you're going to have to match them. You're not going to have to draw them, but you're going to have to match existing graphs. Okay, does anybody have a question about the warm-up first, though? Yes? Okay, so let me go back to this one. She said, why did it go to -6? If I go -3 meters per second for 2 seconds, then after 1 second, I'll be -3 meters away. Do you agree with that? Another second, if I go the same speed, I'll be another -3 meters away. So I'll be a total of -6 meters away after 2 seconds. Okay? Does that make sense? Okay, does anybody else have a question? Okay. All right, so this is what you should have made for the warm-up. If you need to clear it, there's a button that says clear all at the bottom, and you're welcome to start over and sketch exactly what I have on my screen right now. But for today, as I've already mentioned, we have a card sort. Before I do that, though, I want to do one more little practice problem because I haven't done one like this with a word problem. I've only done it with a graph. And I want to make sure you guys know how to answer a word problem because you're going to see one like this on your quiz and on your test next week. Okay, so you might want to jot this down so you have an example to look at later. Up to you though. If you are trying to jot it down, I am on slide 157 in the notes. I'll give you a second to get some paper out, those of you that want to. Okay, so the question says, Dominic jogs 2 miles in 16 minutes before slowing down to walk 1.5 miles in 9 minutes and then running 1 mile in 7 minutes. What is his average speed? Let's start with that one. There's a second question, but let's start with what is his average speed? Okay, we've talked about this equation and we've done this from a graph. We've looked at the graph and said, okay, average speed is total distance divided by total time. Okay, so on the graph we've gone, okay, how far did he go? And we've added those all up and then we've divided by the time. You can do the same thing here. Total distance divided by total time. Okay, so his total distance, he goes 2 miles, then 1.5 more, so that's 3.5, plus 1 more, so that's 4.5. His total distance is 4.5 miles. His total time, we're going to add those numbers up now. 16 plus 9 is 25, plus 7 more is 32. Okay, so it takes him 32 minutes to run or jog or walk, because he changes his speed here, 4.5 miles. So that's what we're going to do is 4.5 divided by 32. That's his total distance divided by his total time. Okay, and we get, let's see. Oh, this is in minutes. That's why I was like, why is this so slow? Okay, we get 0.14 miles per minute. Okay, we could convert this into miles per hour so we have, a better idea of how fast that is or how slow that is. But that's what we get in miles per minute. It doesn't tell us to convert it, so we can leave it like that. Sorry?
0.4 miles a minute.
0.14. Okay, so again, total distance divided by total time. Follow-up question, can you give me his average velocity based on the information I provided? If yes, what is it? If not, what more do you need to know?
You need to, where he's starting.
Okay, I don't necessarily need to know where he starts, but I do need to know which way he goes. Okay, I can't give you an average velocity because I don't know if he's running in a circle, and if so, his displacement and his distance aren't going to be the same, or if he's running in a straight line. If he's running in a straight line, my velocity would be exactly the same as my average speed. I'd just tack a direction on the end. But numerically, the magnitudes would be equal. But I don't know that because I don't know if he's going on some crazy path. Probably is since he's jogging. He probably started where he ended. Okay, or if he is, jogging on a track. Okay, so we don't know. So we can't actually answer the question of his average velocity unless we know which direction he's going on each of those legs. Okay, so I just wanted to go over that, but his average speed, again, you're going to get his total distance divided by his total time. I could have asked you to convert that to miles per hour since that is a unit you're more familiar with. I didn't. If you want to do that for practice, you are welcome to. Okay, it's a pretty easy practice problem though. All right. Because you would just multiply by 60. He's going 8.4375 miles per hour on average. All right, any questions about this one? Okay, just wanted to do an example. So this is what you are doing today. You're going to head to Schoology and open the assignment number 110. There is a digital card sort on Desmos, and this card sort has 3 different types of graphs or representations of motion that you're going to match together because they're going to show the same motion, just like the warm-up. Were those 2 graphs that we made one of them, but those 2 show the same motion. You'd match them together. Okay, you're going to match them up. Each set should have 3 graphs. Each grouping will contain each of one of these types of graphs. And then again, don't forget you have a prediction to test for your RA. So if you haven't discussed that, that would be another thing for you to do. But let me go ahead and show you what this card sort looks like. Okay, when you log into Desmos, you're going to see this. Now yours probably looks like this because your screens are so much smaller than mine. What I'm going to recommend that you do so that you can actually see the cards is to zoom out. Do you guys know how to zoom out on the Chromebooks? Yes. The shortcut is holding Control and pressing minus. If you do that, you can zoom out and you can actually see the things a little bit better. That's the first thing I'd recommend you do. The second thing that I would recommend that you do is there are 3 different types of graphs here. So you're supposed to be matching them with each other, but this is a jumbled mess right now. So what I would start by doing is getting like all of your position time graphs together. They're not going to be ultimately matched together, but if you organize the screen, it'd be a lot easier to see everything. Okay, get all of your motion maps together. Okay, and you can do that by dragging and dropping them. You can actually collapse the stacks. That's what you do when you actually match the three together. Okay, and then get all your velocity graphs together. That way it's a little bit easier to actually see what you're doing instead of looking at this jumbled mess on the screen. Okay, so do whatever you want to do, but this is what I would recommend that you do to at least help you get started. And you can make more than one stack of them. If it goes off, sometimes it'll be too long to fit on the screen because there's quite a few cards here. Okay, but ultimately what you're going to do is this. Let's say, I'm going to zoom back in for a second. Let's pretend for a second that this position time graph matches whatever this is, this velocity time graph. Okay, and that it matches this motion map. Okay, they don't, but let's pretend. You would put them together like this. Okay, if those three, if you think they show the same motion, you would do that, and then you could collapse them like this to get them out of the way, and then keep sorting with the rest of them. I can tell you whether or not you are wrong or right because I can see all of your screens on my computer. So if you think you're at a point where you have everything matched correctly, you're welcome to come ask me and I can check it for you and let you know because this is going to be a good practice for you. I am going to post a key to this. The key is actually a video of me matching them. So I'll post that. That way you can check yourself later on if you don't happen to finish it in class today. But I do want you to be able to do this because on your test and on your quiz, you're going to be asked to match the graphs together. You'll also be asked to do that on your TEKS test at the end of the semester. So it's a skill that you're going to need. But again, a good way to start is by just organizing the screen because otherwise it looks a little overwhelming. So I would move all of my position cards together, all of my motion maps together, and then all of my velocity cards together, and then just pick one to start. This would be an easy one to start with because this one's pretty simple, the one that I actually grabbed first. And so you would look at it and you would say, okay, this object is moving forward at a constant speed of 1 meter per second, and then it stops. That's it. So that's what I would be looking for on my velocity time graph is something moving forward at 1 meter per second and then going to a velocity of 0. Okay, so you should be able to find that. You should also find a motion map that shows that. But this is what you should be doing, and you can make it full screen. That also makes it easier because then you don't have the thing at the top. There's a full screen button. But that should make it easier for you to actually match them up. So go ahead and get to work. If you have questions as you're working, please let me know. And then in addition to this, if you haven't come up with a prediction yet for your RA tomorrow, make sure that you do that. Okay, so y'all need to have that ready to go because we can't test it if you don't have it. And if you don't have it tomorrow and you can't test it tomorrow, your RA will be late. Okay, so if you want to work on that first, you're welcome to do that. I'm going to go ahead and let y'all get to work. Again, if you have questions, please let me know.